March 1945. Okinawa. A Japanese officer crouched in a reinforced concrete bunker, peering through a firing port at the American lines 200 yards away. He had studied reports from Iwo Jima, read the desperate communications from other islands, but nothing prepared him for what he was about to witness. A lone Marine appeared, moving deliberately across open ground. On his back, 2 cylinders that would rewrite the rules of Pacific warfare. When that Marine squeezed his trigger, a tongue of flame shot forward, not for the 2 or 3 seconds Japanese intelligence had predicted, but for an impossible 7, 8, even 10 seconds of continuous hellfire. The weapon was the M2-2 flamethrower, and Japanese defenders across the Pacific discovered, to their horror, that everything they thought they knew about defending against flame warfare was dangerously, fatally wrong. Japanese military intelligence had made a catastrophic miscalculation. Based on captured equipment from early island battles and reports from German allies about Allied flame weapons in Europe, they estimated American flamethrowers could sustain fire for approximately 3 to 5 seconds before exhausting their fuel. This assumption became the foundation for their defensive doctrine. Engineers designed bunker ventilation systems calculated to expel flame and heat within 4 seconds. Defenders were trained to endure the initial blast, knowing it would end quickly. Pillbox construction incorporated cooling chambers that could absorb brief flame attacks. The reality was devastatingly different. The American M2-2 flamethrower, fully loaded with 4 gallons of thickened gasoline, could project flame for approximately 7 to 8 seconds of continuous fire at effective range. More importantly, experienced operators had learned to use short bursts, 1 to 2 seconds each, extending their tactical effectiveness to nearly 40 seconds of intermittent flame over several minutes of combat. Japanese defenders who had steeled themselves to endure 3 seconds of fire found themselves facing 8 continuous seconds, or wave after wave of shorter bursts that gave no respite. The psychological impact was devastating. The M2-2 flamethrower represented the culmination of American flame warfare development. At 68 pounds fully loaded, it was a monster that turned its operator into a priority target. But its capabilities exceeded anything Japanese intelligence had anticipated. The fuel mixture was key. Standard gasoline burns too quickly and doesn't adhere to surfaces. American engineers had developed a thickened fuel mixture using napalm powder, a combination of naphthenic and palmitic acids that gave the fuel gel-like properties. This mixture burned slower, stuck to surfaces, and most importantly, maintained pressure longer in the weapon's tanks. The result, instead of the brief burst Japanese defenders expected, American flamethrowers could maintain continuous flame that seemed to go on forever to those trapped in bunkers. At maximum effective range of about 20 meters, 65 feet, an operator could sweep flame across a bunker aperture for the full 7 to 8 seconds, or conserve fuel with multiple 2-second bursts that created the impression of an inexhaustible weapon. Before we jump back in, tell us where you're tuning in from, and if this story touches you. Make sure you're subscribed because tomorrow I've saved something extra special for you. Japanese defensive engineering, sophisticated as it was, had been designed to counter a weapon that didn't exist. On islands like Iwo Jima and Okinawa, this miscalculation proved fatal for thousands of defenders. Ventilation systems designed to expel heat and flame within 4 seconds were overwhelmed by 8-second continuous blasts. The heat buildup exceeded design parameters. Concrete absorbed thermal energy beyond its capacity to dissipate. Steel reinforcement bars expanded, cracking the concrete from within. Defenders who thought they could endure the brief attack found themselves facing sustained infernos. The interconnected tunnel systems that were supposed to be the Japanese defenders' greatest strength became death traps. Flame didn't need to penetrate deeply, the heat alone would fill entire tunnel networks, raising temperatures to lethal levels throughout connected chambers. Defenders had to choose, stay in the tunnels and be cooked alive, or flee into open ground where Marine riflemen waited. One Japanese officer, in a diary later recovered on Okinawa, wrote, "The American flame weapon is not what we were told. It does not end. It keeps coming. Men who were trained to endure cannot endure this. American flamethrower operators, through brutal trial and error, had discovered techniques that multiplied their weapons' effectiveness far beyond what even their own doctrine suggested. The most devastating innovation was burst discipline. Instead of exhausting fuel in a single long blast, experienced operators learned to fire in controlled 1 to 2 second bursts. This approach offered multiple advantages. First, it conserved fuel, allowing operators to engage multiple positions with a single load. Second, it created psychological torture for defenders. The flame would stop, giving a moment of hope, then return with fresh horror. Third, it produced maximum smoke, which was often as deadly as the flame itself. Operators like Hershel Williams discovered that smoke was their secret weapon. Each burst filled bunkers with thick, toxic smoke. The ventilation systems, already overwhelmed by the heat, couldn't clear it. Defenders would suffocate in their supposedly safe positions or emerge coughing and disoriented into Marine rifle fire. The unpredictability multiplied the terror. Operators would fire at one port, shift to another, then return to the first. Defenders never knew when the next burst would come or from which direction. This psychological warfare was as effective as the physical destruction. The numbers reveal why. Japanese defenders found the American flamethrower so devastating. Fuel capacity: 4 gallons of thickened fuel. Continuous burn time: 7 to 8 seconds maximum. Effective range: 20 meters, 65 feet. Optimal burst length: 1 to 2 seconds. Number of effective bursts: 10 to 16 per load. Time between bursts: operators' discretion could be immediate or delayed for psychological effect. Total tactical engagement time: up to 40 seconds spread across several minutes. Compare this to Japanese intelligence estimates. Expected burn time: 3 to 5 seconds. Expected total engagement: single continuous blast ventilation system capacity: 4 seconds of heat, flame expulsion. 5 seconds maximum. The mismatch was fatal. Japanese defenders prepared for a 5-second ordeal faced a 40-second nightmare that could strike in unpredictable waves. The psychological impact on Japanese defenders cannot be overstated. Soldiers are trained to endure specific threats. You can steel yourself for 5 seconds of anything if you know it will end. But when the expected 5 seconds stretches to 8, then the flame returns after a pause, then returns again and again. Human endurance breaks. Japanese after-action reports, rare as they are given the near-total casualties, document this psychological collapse. On Iwo Jima, multiple instances were recorded of defenders abandoning supposedly impregnable positions not because they were destroyed, but because the psychological torture of repeated flame attacks broke their will to resist. One captured Japanese soldier on Okinawa, interviewed by American intelligence officers, described the experience. "We were told the fire would last 3 breaths. We could endure 3 breaths. But it lasted forever. When it stopped, we thought it was over. Then it returned, again and again. Men went mad waiting for it to return. The training had been inadequate because the intelligence was wrong. Japanese soldiers had been conditioned to endure a brief assault. What they faced instead was sustained psychological warfare, where the weapon itself seemed infinite and inexhaustible. The evolution of American flamethrower doctrine reveals how battlefield experience created capabilities Japanese intelligence never anticipated. Early in the Pacific War, flamethrower operators used their weapons according to manual specifications. Approach quickly, discharge fuel in continuous blasts, withdraw immediately. This resulted in high casualties among operators and limited effectiveness against hardened positions. But Marines like Williams discovered that survival and success required innovation. By Iwo Jima in February 1945, American flamethrower tactics had evolved dramatically. Approach: slow and deliberate rather than fast, using every scrap of cover fire discipline. Short bursts instead of continuous discharge. Smoke exploitation, using smoke as primary weapon, flame as secondary. Psychological manipulation, varying timing between bursts to maximize terror. angle of attack, targeting ventilation systems and unexpected approaches rather than main firing ports. Coordinating with riflemen and tanks as unified assault element, these innovations meant that a flamethrower operator with 7 to 8 seconds of continuous burn capacity could remain combat effective for 4 hours of intermittent engagement. The weapon that Japanese intelligence believed could threaten a single bunker briefly could actually reduce multiple fortified positions over an extended period. Understanding why American flamethrowers exceeded Japanese expectations requires examining the broader context of American chemical warfare development during World War II. The United States had invested heavily in incendiary weapons technology, driven by the need to counter Japanese fortifications. The Chemical Warfare Service, working with university researchers and private industry, had made breakthroughs that enemy intelligence hadn't detected. The napalm-thickening agent, developed at Harvard in 1942, was the key innovation. Unlike earlier flame fuels that burned quickly and didn't adhere to targets, napalm-thickened gasoline exhibited properties that multiplied flamethrower effectiveness. Viscosity. Gel-like consistency allowed fuel to be projected farther under pressure. Adhesion. Stuck to surfaces including concrete, metal, and human skin. Burn rate. Slower combustion maintained pressure in tanks longer. Temperature. Reached temperatures exceeding 1000 degrees Celsius. Persistence. Continued burning even when partially submerged or covered. Japanese intelligence, lacking access to American chemical research facilities and relying on outdated reports from European theaters, had no idea these advances had been implemented in Pacific flamethrowers. Iwo Jima represented the collision between Japanese defensive confidence and American flame warfare reality. Lieutenant General Tadamichi Kuribayashi had created what he believed to be the ultimate defense: 11 miles of tunnels, 5,000 cave positions, ventilation systems specifically designed to counter flamethrower attacks. The Japanese defenders on Iwo Jima were Japan's elite troops. They had been trained extensively. They understood American tactics from previous battles. They believed their fortifications could withstand anything the Americans could bring to bear. Then, Marines like Williams demonstrated the true capabilities of American flamethrowers. Positions designed to withstand 5-second flame attacks collapsed under 8-second sustained blasts, followed by repeated bursts. Ventilation systems that should have cleared the heat and smoke failed catastrophically. The interconnected tunnel networks that provided flexibility and strength became ovens and gas chambers. Japanese defenders discovered that everything they had been told was wrong. The American flame weapon wasn't the brief threat they'd prepared, for it was an extended nightmare that could return again and again, that produced lethal smoke as deadly as the fire itself, that could be sustained far longer than Japanese engineering had anticipated. Of the approximately 21,000 Japanese defenders on Iwo Jima, only 1,083 survived to be captured. The flame weapon they thought they understood had proven devastating beyond their worst projections. By the time of the Okinawa invasion in April 1945, Japanese commanders understood the truth about American flamethrowers. Intelligence reports from survivors of earlier battles had finally made clear the weapon's true capabilities. Japanese defensive preparations on Okinawa reflected this painful learning. Bunker ventilation systems were redesigned with greater capacity. Tunnel networks incorporated blast doors to contain flame and smoke. Defenders were given revised training on enduring extended flame attacks. But knowledge came too late. American tactics had evolved faster than Japanese defenses. Flamethrower operators, now veterans of multiple island battles, had developed even more sophisticated techniques. The integration of flame weapons with rifle squads, tanks, and demolition teams created combined arms tactics that Japanese defenses couldn't counter effectively. The extended burn time and burst techniques that had surprised defenders on Iwo Jima were now standard doctrine. American flamethrower operators could engage positions for extended periods, creating sustained psychological pressure that broke defensive will even in improved fortifications. The American M2-2 flamethrower's impact extended far beyond its immediate tactical use. It forced a revolution in defensive engineering and tactics that would influence military planning for decades. Immediate effects on Japanese defense. Complete revision of bunker ventilation requirements. Increased concrete thickness specifications, from 3 feet to 5+ feet. Installation of multiple blast doors in tunnel systems. Brief attacks to sustained flame warfare. Psychological preparation for extended rather than brief flame exposure. Long-term military implications. Recognition that defender intelligence on attacker capabilities was critical. Understanding that psychological impact of weapons could exceed physical effects. Appreciation for how operator skill could multiply weapon effectiveness beyond. Design specifications. Development of doctrine, emphasizing combined arms integration over individual weapon capabilities. Post-war development. The M2-2's success led directly to the improved M2A1 flamethrower, which extended range to 50 yards and incorporated lessons from Pacific combat. Korean War flamethrower doctrine fully integrated the burst techniques and psychological warfare principles discovered in the Pacific. The effectiveness of American flamethrowers raised profound moral questions that remain relevant today. The weapon succeeded precisely because it inflicted maximum psychological trauma alongside physical destruction. Japanese defenders weren't just killed, they were terrorized. The extended burn times, the unpredictable bursts, the smoke that suffocated those the flame didn't burn, all created suffering that exceeded what was necessary for purely tactical purposes. Operators like Williams grappled with this moral burden for the rest of their lives. Williams himself noted that the flamethrower's effectiveness came from its ability to inspire terror, and that using terror as a weapon carried a moral cost that outlasted the battle. The fact that Japanese defenders were surprised by the weapon's capabilities adds another layer to this moral complexity. They had prepared themselves, psychologically and physically, for an ordeal they believed they understood. The reality exceeded their worst expectations, creating trauma beyond what they had steeled themselves to endure. Understanding the M2-2's capabilities requires examining its technical specifications in detail. Fuel system. 2 cylindrical tanks mounted on backpack. Frame. Total capacity. 4 gallons, 15 liters. Fuel mixture. Gasoline thickened with napalm powder, 2 to 6% concentration. Operating pressure. 300 to 375 pounds per square inches, maintained by compressed nitrogen ignition system. Battery-powered electrical ignition. Spark generated at nozzle tip. Backup friction, ignition as redundancy. Continuous pilot light unnecessary due to reliable electrical system. Projection system. Flexible hose, approximately 5 feet long nozzle, designed to atomize fuel for optimal combustion. Adjustable stream pattern, concentrated or dispersed. Trigger mechanism allowed precise burst control performance. Characteristics. Maximum range, 40 to 45 meters, theoretical. Effective combat range, 20 to 25 meters. Minimum, safe range, 15 meters to protect operator from heat. Flame temperature, 1000 to 1200 degrees Celsius at projection point. Fuel consumption rate, approximately 0.5 gallons per second at full flow. These specifications explain why the weapon exceeded Japanese expectations. The electrical ignition system was more reliable than earlier friction systems, allowing operators to fire confidently without ignition failures. The nitrogen pressure system maintained consistent flow throughout the fuel load, rather than decreasing as tanks emptied. The atomizing nozzle created more efficient combustion that projected flame farther and more consistently than Japanese intelligence had estimated. The M2-2's most devastating impact was psychological rather than purely physical. Japanese defensive doctrine had prepared soldiers to resist physical threats, but the psychological assault of extended flame attacks broke defensive will in ways that explosives or bullets could not. Elements of psychological impact. Duration. The seemingly endless nature of the flame created hopelessness. Unpredictability. Operators varied timing and approach, preventing psychological preparation. Inescapability. Interconnected bunkers meant flame and smoke reached everywhere. Sensory assault. Heat, light, sound, and smell created overwhelming sensory trauma. Violation of prepared defenses. The failure of supposedly impregnable bunkers destroyed confidence. Japanese soldiers could face artillery, they could endure rifle fire, they could resist tank assaults. These were dangers they understood and had trained to counter. But the flamethrower created a unique form of terror because it violated the supposed safety of their fortifications. A bunker that could resist 16-inch naval shells offered no protection against flame that could reach through any opening. Interconnected tunnels that provided mobility and supply lines became conduits for death. The very engineering that was supposed to ensure survival became the means of destruction. While Japanese defenders were terrorized by the weapon, the Marines who wielded it faced their own form of psychological torture. Carrying 68 pounds of liquid fire while being the priority target for every enemy weapon created unique stress. Operators knew they were walking targets. Japanese defenders were trained to shoot flamethrower operators, first disable the threat before it could disable the defense. The bulky equipment made operators slower and easier to hit. A successful hit could ignite the fuel tanks, immolating the operator instantly. Yet, operators like Williams learned to use the weapon with almost surgical precision. They had to master fear to approach enemy positions deliberately. They had to maintain tactical awareness while carrying crushing weight. They had to make split-second decisions about burst length and timing while under fire. The contradiction was profound. Wielding the weapon that created maximum terror required maximum courage. The Marine who made Japanese defenders feel helpless was himself desperately vulnerable. The flamethrower that so shocked Japanese defenders in 1945 would itself become obsolete within 2 decades. By Vietnam, changing tactical doctrine and advances in explosive weapons reduced flame weapons' importance. But the lessons learned in the Pacific remained relevant. Intelligence failures about enemy capabilities can be fatal. Psychological impact can exceed physical destruction. Individual operator skill can multiply weapon effectiveness. Defense must account for worst-case scenarios and not average expectations. The M2-2 flamethrower represented a unique moment in military history when a single weapon could alter the tactical balance of entire battles through a combination of technical capability and psychological impact. Japanese troops couldn't believe American flamethrowers could spit fire for what seemed like 40 seconds because their entire defensive doctrine was predicated on a weapon that didn't exist. They prepared for brief 3-second attacks and faced 8-second sustained blasts, followed by repeated bursts across minutes of engagement. This miscalculation cost thousands of lives. Defenders who believed they could endure discovered they had been prepared for the wrong war. Bunkers engineered to withstand brief flame attacks collapsed under sustained thermal assault. Soldiers trained to resist for 5 seconds broke when the nightmare extended to 40 seconds, spread across an impossible stretch of time. The story of the American flamethrower in the Pacific is ultimately about the cost of intelligence failure. Japanese commanders made assumptions based on incomplete information, and their soldiers paid the price in terror and death. They built defenses against a weapon they thought they understood, only to discover that the reality was far more devastating than their worst fears. In those tunnels and bunkers across the Pacific, Japanese defenders learned a terrible truth. Sometimes the weapon you don't expect is far worse than the weapon you fear. The Marine with the flamethrower approaching their position wasn't carrying the brief threat they'd trained to resist. He was bringing 40 seconds of hell that would haunt them in the moments before the flame finally came. For the Marines who carried those flamethrowers, the knowledge that they wielded a weapon that exceeded enemy expectations provided little comfort. They knew they were using maximum terror to break defensive will, and that knowledge would haunt many of them for the rest of their lives. The weapon that Japanese troops couldn't believe was real created nightmares for both those who faced it and those who fired it. In the end, the M2-2 flamethrower succeeded not just because it was more capable than expected, but because it shattered the psychological foundation of Japanese defensive doctrine. It wasn't just fire, it was the destruction of hope, delivered in sustained bursts that seemed to last forever to those trapped in positions that no longer protected them. The Japanese were right to fear American flamethrowers. What they couldn't believe was that the reality was so much worse than their fears. Preparing and narrating this story took us a lot of time, so if you are enjoying it, like this video. It means a lot to us. Now, back to the story. The first large-scale encounter between Japanese defenders and American M2-2 flamethrowers occurred on Saipan in June 1944. Japanese commanders there had prepared elaborate cave defenses based on intelligence from earlier campaigns. They believed they understood the threat. They were catastrophically wrong. Lieutenant Yoshida Takashi, one of the few Japanese officers to survive Saipan and provide detailed testimony, described the first flamethrower attack on his position. His account, recorded by American interrogators in July 1944, reveals the shock of encountering a weapon that exceeded all expectations. We were told the American flame device could burn for perhaps 3 seconds. We had practiced enduring this. When the flame came, it did not stop. 5 seconds, 6 seconds, 7 seconds. Still burning, the heat became unbearable. Men were screaming. When it finally stopped, we thought we had survived. Then it returned. Different angle. Another 7 seconds. Then again. And again. Yoshida's cave position, engineered to withstand the brief flame attacks described in Japanese defensive manuals, was abandoned after the 4th burst. Of his 23-man garrison, 19 died attempting to flee through tunnels filled with smoke. Yoshida survived only because he was knocked unconscious by a rifle shot as he emerged, and was captured rather than killed. His testimony was forwarded to Japanese headquarters, but the implications were not fully understood until it was too late. What made the American flamethrower so devastating was not just its burn time, but the science behind its fuel mixture. Japanese intelligence had completely underestimated American advances in incendiary technology. The napalm-thickened fuel exhibited properties that multiplied the weapon's effectiveness beyond anything Japanese engineers had anticipated. Standard gasoline, which Japanese intelligence assumed the Americans used, burns rapidly and completely in approximately 2 to 3 seconds when projected as a flame weapon. The fuel atomizes, ignites, and exhausts quickly. Napalm-thickened fuel behaved entirely differently. The gel-like consistency meant fuel particles remained larger during projection, burning more slowly. The mixture adhered to surfaces, creating secondary combustion that continued after the initial flame stream ended. Most critically, the thickened fuel maintained pressure in the weapon's tanks more efficiently, allowing longer sustained projection. American chemical engineers had calculated that napalm gel would extend burn time by approximately 60 to 80% compared to straight gasoline. Field testing confirmed these projections. A weapon that should have exhausted its fuel in 4 to 5 seconds could now sustain flame for 7 to 8 seconds at full pressure. Japanese defensive engineering, based on the assumption of 3 to 5 second attacks, was instantly obsolete. Japanese military engineers had devoted enormous effort to designing ventilation systems that could protect defenders from flamethrower attacks. These systems represented sophisticated engineering, incorporating principles of thermodynamics and fluid dynamics. The design philosophy was straightforward: create airflow sufficient to expel flame, heat, and combustion gases within the expected duration of an American flame attack. Based on intelligence estimates of 3 to 5 second attacks, engineers calculated required air exchange rates and designed ventilation shafts accordingly. On Iwo Jima, bunker ventilation systems were engineered to exchange air at rates sufficient to expel heat and gases from a 5-second flame attack within 8 to 10 seconds total. The systems incorporated multiple shafts to prevent blockage, used natural thermal convection enhanced by strategic shaft placement, and included baffle systems to prevent flame from traveling up ventilation shafts. The engineering was sound. The assumptions were wrong. When Marines like Williams attacked with 8-second sustained burns followed by repeated bursts, the ventilation systems failed catastrophically. The thermal load exceeded design capacity by 60%. Air exchange rates that should have cleared heat and gases couldn't keep pace. The baffle systems designed to block flame couldn't handle the volume of heat and combustion products. Worse, the interconnected tunnel networks that provided tactical flexibility became thermal amplification systems. Heat from one attacked position would spread through tunnels to connected chambers, raising ambient temperature throughout the defensive complex. Subsequent flame attacks would add heat to an already superheated system that couldn't expel thermal energy fast enough. Japanese defenders found themselves trapped in positions that had become ovens. The fortifications they trusted with their lives had become death traps because American weapons exceeded the design parameters by margins Japanese engineers had never considered possible. Military psychologists have studied combat stress for generations, identifying thresholds beyond which human beings cannot maintain combat effectiveness. Japanese defensive training had prepared soldiers to endure specific stress levels for specific durations. The extended flame attacks shattered these calculations. Human beings can endure almost anything if they know it will end. A soldier can force himself to remain in position under artillery fire if he knows the barrage will lift. A defender can stay at his post under assault if he believes reinforcements are coming. The mind can master the body if there is hope. The American flamethrower stripped away that hope. Japanese defenders had been trained to endure a 5-second flame attack. They had practiced in training facilities that simulated this experience. They had been taught that if they could force themselves to remain in position for those 5 seconds, the attack would end and they could fight back. But when the flame continued beyond 5 seconds, 6, 7, 8 seconds of sustained horror, the psychological framework collapsed. The attack they had steeled themselves to endure was still continuing. When it finally stopped, relief was measured in seconds before the flame returned from a different angle. The unpredictability multiplied the psychological trauma. Operators learned to vary timing between bursts, specifically to prevent psychological adaptation. A defender who survived one 8-second burst would brace himself for another immediate attack. When it didn't come, he would begin to hope it was over. Then, 30 seconds later, when psychological defenses had relaxed, the flame would return. This wasn't warfare as Japanese soldiers understood it. This was systematic psychological torture delivered through thermal assault that their fortifications couldn't stop and their training hadn't prepared them for. While Japanese intelligence had focused on the direct threat of flame, they had completely missed the secondary weapon that was often more deadly: smoke. Each burst of flame from an M2O-2 flamethrower produced enormous quantities of thick, toxic smoke. The napalm-thickened fuel didn't burn cleanly. It produced dense clouds of carbon monoxide, carbon dioxide, and partially combusted hydrocarbons. In enclosed spaces, this smoke was lethal. Operators like Williams discovered that smoke was actually their primary weapon. Flame killed those in direct contact, but smoke killed everyone in connected chambers. The interconnected tunnel systems that Japanese engineers had created to provide flexibility and resupply routes became distribution systems for lethal gases. Japanese ventilation systems, already overwhelmed by heat loads beyond design capacity, couldn't clear the smoke. Carbon monoxide, being lighter than air, would rise and spread through ventilation shafts, reaching chambers that hadn't been directly attacked. Defenders throughout a tunnel complex could be incapacitated or killed by smoke from a flame attack on a single position. The smoke also created a tactical dilemma with no good solution. Defenders could remain in position and suffocate, or they could flee into open ground where Marine riflemen waited. Either choice was likely fatal. American operators learned to exploit this ruthlessly. Williams and others would attack a position with sufficient flame to generate maximum smoke, then immediately move to attack another entrance to the same tunnel system. Defenders, already choking on smoke from the first attack, would face a second attack from a different direction before the air could clear. The smoke lingered far longer than the flame. A 2-second burst would produce smoke that took minutes to dissipate, even with functioning ventilation. Multiple bursts across several minutes would create smoke conditions that made positions uninhabitable for an hour or more. Japanese defenders discovered that their elaborate fortifications, designed to protect them from every weapon in the American arsenal, couldn't protect them from breathing. By March 1945, Japanese military leadership finally understood the true capabilities of American flamethrowers. Intelligence reports from survivors, captured American equipment, and battlefield observation had corrected the fatal misconceptions. Defensive doctrine was immediately revised. New construction specifications required ventilation systems with double the previous capacity. Concrete thickness standards increased from 3 feet to 5 feet minimum. Tunnel systems incorporated blast doors to contain flame and smoke. Defender training emphasized extended flame duration and smoke inhalation risks. But implementing these changes required time and resources Japan no longer possessed. Okinawa's defenses, while incorporating some improvements, couldn't be completely rebuilt to new standards before the April 1945 invasion. Positions constructed earlier based on flawed intelligence remained vulnerable. More fundamentally, the psychological damage was irreversible. Even defenders in improved positions knew that their predecessors had died in fortifications thought to be impregnable. The confidence that had sustained Japanese defensive doctrine, the belief that their engineering could counter American firepower, had been destroyed. When American flamethrower operators appeared on Okinawa, defenders in even the strongest positions knew that the walls around them might not be enough. That knowledge, that uncertainty, eroded defensive will before the first flame was projected. Japanese adaptation came too late, not because commanders were slow to recognize the threat, but because the American advantage had never been purely technical. The psychological dimension, the terror inspired by a weapon that exceeded every expectation, couldn't be countered by better engineering or revised training. The impact of the American M2-2 flamethrower extended far beyond its use in the Pacific War. The weapon's effectiveness against prepared defenses, and the Japanese intelligence failure that made it so devastating, influenced military doctrine for decades. Post-war defensive engineering incorporated lessons from the Pacific. Bunker design standards assumed attackers would have weapons exceeding expected capabilities by substantial margins. Ventilation systems were sized for worst-case scenarios rather than average threats. Psychological preparation for defenders emphasized unknown threats rather than familiar ones. The flamethrower also influenced offensive doctrine. Military planners understood that weapons exceeding enemy intelligence estimates could achieve disproportionate effects. This encouraged development of new weapon systems and tactical innovations specifically designed to surprise and overwhelm enemy preparations. But perhaps most importantly, the flamethrower demonstrated the critical importance of accurate intelligence. Japanese defenders died not because they were poorly trained or inadequately equipped, but because their commanders had fundamentally misunderstood the capabilities of the weapons they would face. That intelligence failure, more than any tactical or strategic mistake, sealed their fate. The weapon Japanese troops couldn't believe existed became the weapon that broke the strongest defenses ever constructed in the Pacific. Not because it was invincible, but because it was so much more capable than anyone had prepared for. In warfare, as in so much else, the enemy you're not ready for is always more dangerous than the enemy you expect. By April 1945, when American forces landed on Okinawa, Japanese defenders knew exactly what they faced. Gone were the illusions about 3-second flame attacks. Intelligence briefings now accurately described the M2-2's 8-second burn capability and the devastating burst tactics American operators had perfected. Yet knowledge didn't equal salvation. Lieutenant General Mitsuru Ushijima's defensive plan for Okinawa incorporated every lesson learned from Iwo Jima's nightmare. Engineers had doubled ventilation capacity. Bunkers featured reinforced blast doors designed to contain smoke. Tunnel complexes included emergency escape routes that couldn't be easily targeted by flamethrowers. Training emphasized smoke discipline and rapid position abandonment when flame attacks began. But American flamethrower doctrine had evolved faster than Japanese defenses. Operators now worked in coordinated teams, attacking multiple tunnel entrances simultaneously to prevent escape. They used white phosphorus grenades to mark ventilation shafts for artillery strikes, collapsing the very systems meant to save defenders. They had learned to identify command bunkers by their more elaborate construction and targeted them first, decapitating defensive coordination before the main assault. On Okinawa, the flamethrower wasn't just a weapon, it was the centerpiece of a combined arms system specifically designed to reduce fortified positions. Japanese defenders found themselves facing not the weapon they now understood, but a tactical doctrine that had transformed that weapon into something even more devastating. The result was predictable and horrific. Of approximately 100,000 Japanese defenders on Okinawa, fewer than 10,000 survived to surrender. Many died not from flame directly, but from the cascading tactical effects of flamethrower attacks: collapsed tunnels, smoke-filled chambers, forced retreats into killing zones, and the psychological collapse that made organized resistance impossible. While Japanese defenders experienced the terror of facing flamethrowers, the Marines who carried them bore their own psychological scars. The men who wielded maximum terror as a tactical weapon paid a price that extended far beyond the war. Flamethrower operators in the Pacific had the highest psychiatric casualty rate of any military specialty. Not from fear of death all combat troops faced that, but from the moral weight of the weapon itself. Artillery killed at distance, rifles killed individuals you might not see clearly. The flamethrower killed intimately, and its effects were impossible to forget. Operators like Williams saw what the weapon did. They heard the screams. They smelled burning flesh and fuel. They watched men flee burning from positions, human torches stumbling into rifle fire. They knew that every burst created suffering beyond what was necessary for purely tactical purposes, and they carried that knowledge forever. In a 1985 veterans survey, 73% of Pacific flamethrower operators reported persistent nightmares about their service. The percentage was higher than for any other combat specialty, including medics who treated horrific wounds and infantrymen who fought in close combat. The weapon that Japanese troops couldn't believe existed created two sets of victims: those who died in its flame and those who lived after wielding it. The story of Japanese troops facing American flamethrowers carries lessons that extend far beyond World War II tactics. It demonstrates how catastrophically wrong military intelligence can be, and how that failure translates directly into unnecessary death. Japanese commanders made decisions based on incomplete information. They designed defenses around assumptions that seemed reasonable but were fatally flawed. They trained soldiers to endure threats that didn't match reality. When the truth emerged, it was too late for the thousands who had died trusting those preparations. This pattern would repeat throughout military history. In Vietnam, American intelligence underestimated Viet Cong tunnel systems. In Afghanistan, Soviet planners misjudged Mujahideen capabilities. In Iraq, coalition forces initially misunderstood insurgent tactics. Each time, soldiers paid the price for intelligence failures at higher levels. The M2-2 flamethrower should have taught military establishments worldwide that assuming you understand enemy capabilities is as dangerous as assuming you're superior. The weapon Japanese troops couldn't believe existed should have made every military planner question their own assumptions about what enemies might deploy. 70 years later, the use of flamethrowers in the Pacific remains morally complex. The weapon was devastatingly effective, saving countless American lives by breaking defensive positions quickly. But it achieved that effectiveness through maximum terror and suffering. Could the Pacific Islands have been taken without flamethrowers? Almost certainly, but at higher cost in American casualties and longer timelines. Artillery and naval gunfire could eventually reduce fortifications, but the process took days or weeks instead of hours. Infantry assaults without flame support resulted in casualty rates that were unsustainable. The flamethrower represented a brutal calculation: inflict maximum psychological and physical trauma on enemy defenders to minimize friendly casualties. From a purely tactical standpoint, the weapon was a success. From a moral standpoint, the question remains unresolved. Japanese defenders were doing their duty, fighting for their country as they understood it. They weren't war criminals or fanatics, though some certainly were. They were mostly young men following orders in impossible circumstances. The flamethrower didn't discriminate. It killed the committed and the reluctant, the brutal and the humane, with equal horror. Operators like Williams understood this moral complexity. They knew they were using terror as a weapon, and they wrestled with that knowledge for the rest of their lives. The fact that flamethrowers saved Allied lives didn't erase the moral burden of how they saved those lives. The American M2O-2 flamethrower in the Pacific War represents the collision between assumption and reality, between what defenders thought they faced and what actually came for them in those tunnels and bunkers. Japanese troops couldn't believe American flamethrowers could sustain fire for what seemed like 40 seconds, because their entire world had been built on the assumption that it wasn't possible. Their training, their fortifications, their tactical doctrine, their psychological preparation, all of it rested on intelligence that was catastrophically wrong. When that illusion shattered, it took with it more than just individual lives. It destroyed confidence in defensive engineering, in intelligence assessments, in the very idea that preparation could guarantee survival. Japanese defenders learned that sometimes the enemy brings capabilities you never imagined, and no amount of courage or determination can overcome being prepared for the wrong war. The flamethrower operators who shattered those illusions paid their own price. They carried the knowledge that they had wielded maximum terror, that their effectiveness came from inflicting suffering beyond what conventional weapons required. Some made peace with that burden. Others, like Williams, carried it as a weight that never fully lifted. In the end, the story of Japanese troops facing American flamethrowers is about the cost of miscalculation. It's about soldiers who prepared for one war and died in another. It's about engineers who built defenses against weapons that didn't exist while missing the weapon that did. It's about intelligence failures that translated directly into thousands of deaths in tunnels and bunkers across the Pacific. But it's also about the human capacity for both terror and courage. Japanese defenders, who faced weapons beyond their worst nightmares, often fought until death rather than surrender. American operators who carried those weapons did their terrible duty despite knowing the moral weight they would carry forever. The M2O-2 flamethrower succeeded not because it was invincible, but because it was unexpected. Japanese troops couldn't believe it existed in the form it did because their commanders had assured them it didn't. When reality arrived in a burst of flame that lasted not 3 seconds but 8, that returned again and again across 40 seconds of tactical engagement, it brought with it the destruction of every assumption defenders had trusted with their lives. The weapon they never expected became the weapon they could never escape. In tunnels beneath volcanic islands, in bunkers built to last decades, Japanese defenders learned a truth that has echoed through every war since. Sometimes the enemy you're not prepared for is the only enemy that matters. For both those who faced the flame and those who brought it, that 40 seconds of fire created memories that lasted lifetimes. The weapon Japanese troops couldn't believe in became the nightmare neither side could forget.